Okay, so we have one more question here that it says that the diameters of circles in millimeter drawn in design are given below. So these are the diameters of circles in millimeter. Diameters of circles in millimeter drawn in a design. They are given in this table. So suppose that you have something like this. So these are basically diameters, which will be basically your classes, and this is the number of circles. And that would be basically, for example, 33 to 36, 37 to 40, 37 to 40, then you have 41 to 44, 41 to 44, and then you have 45 to 48, and then you have 45, 45 to 48, and then you have 49 to 52, 49 to 52. So you have 15, have 17, have 21, have 22, and you have 25 here. So that means that basically all the circles whose diameters were anywhere between or anywhere from 33 to 36 millimeters, this is in millimeters, the number of those circles were 15. Basically the circles whose diameters were anywhere from 37 to 40, the number of those circles was 17. The circles whose diameters were from 41 to 44, the number of those circles was 21, and so on and so forth. Now what you want to do is calculate the standard deviation and mean diameter of the circles. You want to calculate standard deviation and mean diameter in those circles. So now the problem that you first need to take care of in this data is that your classes are not continuous, meaning that, for example, your classes go from 33 to 36, and then 36 over here, and then the next class starts from 37 to 40, then 41 to 44, and so on and so forth. Now, in order to take care of that problem, what you need to do is make your classes continuous. And so you can see that, for example, the difference, or basically the difference between these two numbers is 1 unit. So that means that you have to add basically 36, basically if you have your 33 to 36, for example, here, and then after that you have 37 to 40, right? Now what that means is that, and then you have, for example, 41 to 44, and so on and so forth. So now the distance over here, 36 to 37, this is 1 unit. Again you have 1 unit over here, and so on and so forth. So somehow you need to basically cover this 1 unit. But since you want basically right now the class sizes are equal, meaning that excuse me, meaning that, for example, 36 minus 33 is equal to 3. 37 or 40 minus 37 is equal to 3. 44 minus 41 is equal to 3, and so on and so forth. So you want your class sizes to remain equal. So what you can do is that you can add 0.5 to 0.5, which is basically half of one unit. Add 0.5 or half to basically the upper limit, of each class. And also you can, what you need to do is subtract, and also what you need to do is subtract again 0.5 from the lower limit, of every class. So that means that if you subtract 0.5, for example, from here, this becomes 36.5. Add 0.5 to the upper limit here, that becomes 36.5, and then the same thing keeps happening in all of your classes, and then all of your classes become continuous. So then what I need to do is just do the same, meaning that I take these classes. I'm going to write this a little bit. I think I'm going to need the space here. So what I'm going to do is just write this as frequency, and so I'm going to write this as f of I, and my f of i's were 15, 17, 21, 15, 17, 21, 22, and 25. And then these classes, these new classes, go from basically 22.5 all the way up to 36.5. Now over here again, 36.5 all the way up to 40.5, 40.5 all the way up to 44.5, 44.5, 44.5 all the way up to 48.5, and 48.5 all the way up to 52.5, 52.5. And now my classes are continuous. 40.5. It says at first make the data continuous by making the classes as 32.5. Oh, that's 32.5. I'm sorry. That's 32.5. That's not 22.5, but 32.5. 36.5, 36.5. 40.5, 40.5, 44.5, 44.5, 48.5, 48.5, 52.5. Okay, so now that my classes are, now that our classes are continuous, what I can do is basically calculate, I want to calculate mean standard deviation and mean diameter. So Standard deviation, I can use the shortcut method, or I can use sigma basically. We said that basically sigma squared was equal to basically sigma f of I times x of I minus x bar all squared divided by sigma f of I. Now to do this, I need to find my x of i's and then see what happens with my x of I. So I'm going to need to find the class marks. So because I don't have any x of i's as of now. Right now I have all of these classes, but I have no x of i's. So I take this as my x of I, and for example this is 32.5. Let me write this properly. This is 32.5, 36.5. So 32.5 and 36.5, if I add them together, I get 0, 1, and that is a 9, and that is a 6, so 69. 69 divided by 2 is 34.5, for example. So this becomes 34.5. Or this class over here, for example, 36.5 plus 40.5, that's 77. 77 divided by 2, you'll get 35, and this is 3.5, that's 38.5. 38.5. Next you have, for example, 40.5, 44, that's 89 divided by 2, you'll get 44.5. 44.5. So the difference over here is 4, and the difference over here is supposed to be 40 and 44.5. No, that's not right. That is not right. So over here I have 88, 89. So that's a 40, and that's 4.5, that's 40. What? So 40.5 and 44.5, add them together, you will get 0, 1, and that's a 5, and that's an 8, that's 85. That's 85. So you get 42.5. 42.5. And then you can see that the difference over here is 4. So that's 46.5, and that would be 50.5. Let's see if you have done this right. So for example, 48.5 plus 52.5, that would be 0, 1, 11, 1, and that's a 10, so that's 101, that's 50.5. 50.5, so everything is so far correct. Now, what I need to do, this is now, this is of course deviance. No, not deviance, but variance. This is called variance. If you take the square root of this, that would be basically, the square root of this would be basically sigma, and that sigma would be basically standard deviation. Standard deviation. So what we can do is that we can calculate variance and then take the square root of that to calculate standard variation. Now let's see how we can first calculate the, let me write down this formula here. So sigma squared is equal to sigma f of I times x of I minus x bar whole squared divided by sigma f of I. Now, so first we need to calculate x bar. So to calculate x bar, the usual method, you can use x bar, you can use the formula x bar is equal to sigma f of I x of I over sigma f of I. Now f of I is over here, x of I is over here, so you would have to multiply all of these numbers together, which would take forever. I'm not going to do that. The other thing that you can do is that you can use, for example, the formula, for example, x bar is equal to a plus, for example, sigma f of I d of I divided by sigma f of I, which is the assumed mean method to find the average of all of your x of i's. But let's do one of these probably. Let's see how that goes. Or what you can do, which would be, I suppose, the easiest way to do it, is just use the shortcut method. The shortcut method seems to be the easiest one. It does basically, if you take this idea a little bit further, you would end up with basically x bar is equal to, for example, a plus sigma f of I u of I divided by sigma f of I times h. And this is called the step deviation method. Step deviation method. This we used to use in order to find the mean of some basically observations. But if you use the shortcut method, in the shortcut method, then this method will practically be used, and then also you will have access to that formula, which is basically sigma is equal to, I'm not sure about this, let me see. You will have access to sigma, which is sigma of x. You will have it is as basically h over n times the square root of, for example, n times sigma of f of I y of I squared as I goes to 1 to n minus sigma of f of I y of I as I goes from 1 to n, and you square this, and then you take the square root of this whole thing, and this would be basically standard deviation, which is what we want to calculate. Standard deviation. So I think this might be the best way to do it. So let's do this one. First, I mean, in the beginning I was a little bit skeptic about this whole method of the shortcut method, but it seems to be the best way to do just about anything. So I mean, as long as you want to calculate mean and standard deviation, or mean and basically variance, or even if the only thing that you want to calculate is variance, again, that shortcut method seems to be the best one. So let's use the shortcut method. Okay. So now using the shortcut method, we said that we needed basically we had a couple of things. First of all, you need to take the assumed mean of the data. For example, I take the assumed mean as, for example, 42.5. I take this as the assumed mean of the data. take this as A, and the class size, basically your A is now 42.5, and your class size H is basically, well, your class size, meaning that, for example, 44.5 minus 40.5, which is equal to 4. Or, for example, 48.5 minus 44.5, which is equal to 4, and so on and so forth. So that is equal to 4. And basically the way that this is basically your x of I want to define some other variable y of I in such a way that basically I take my x of I and subtract from that this assumed mean so that the number becomes smaller. For example, 34.5 minus 42.5, I would be some negative number about, I suppose, negative 8 or so, I don't know. Or for example, 46.5 minus 42.5 is going to be just 4. As opposed to being some large number with a decimal point and so on and so forth. So I take my x of I and subtract from that the assumed mean of my x of i's, meaning that I'm kind of assuming, or I am actually assuming, that the mean of these observations is 42.5. okay, and then I take that whatever that gives me, I divide it by the class size, by h, meaning that, for example, over here I take, for example, I want to make this number easier to deal with. The number is 46.5. Subtract from that the assumed mean, which is 42.5, and then divide the whole thing by the class size, which is 4. So now this is going to give me 4 divided by 4, which is equal to 1. Now you can compare these two numbers. Of course, 1 is much easier to deal with than, for example, 46.5. That's basically how this formula works. And I call this y of I. So now what that means is that y of I, whose value basically is going to be this, is going to be, for example, 34.5 minus, for example, 42.5 divided by h, which is equal to 4. Now 42.5 minus 34.5 is equal to 0, 8. So that's negative 8. Negative 8 divided by 4 is equal to negative 2. That is negative 2. Or 38.5, for example, 38.5 minus 42.5 divided by 4 is basically 42.5 minus 38.5 is equal to the difference is 6, I suppose, 0 and 12, 4, and since it's 38 minus 42, that's a negative 4. So negative 4 divided by 4 is equal to negative 1. And over here I have 42.5 minus 42.5 is equal to 0, and 0 divided by 4 is equal to 0. 46.5 minus 42.5 is 4. 4 divided by 4 is equal to 1. 50.5 minus 42.5 is equal to 8. 8 divided by 4 is equal to 2. And you see these numbers are very easy to deal with as compared to these numbers, right? These numbers, compare them to these numbers, and you will then you can appreciate basically how this method works. Now, what you need to do is that is that we found some relationship between x bar and y bar. We said that x bar is equal to a plus h times y bar, right? So that means that first, if I based on the y of I that I have here, if I calculate y bar, then I can, based on that, then I can calculate x bar. So now, you know that x bar, for example, normally what that means is that it's equal to sigma f of I x of I over sigma f of I. And based on that, you can say that y bar is equal to, for example, sigma f of I y of I divided by sigma f of I. And by the same logic, if you had z bar, for example, that would be sigma f of I z of I divided by sigma f of I, and so on and so forth. Just changing the variable. And so what that means is that if I want to calculate y bar, which is used in this formula, sigma f of I y of I need to calculate that. So I calculate f of I y of I. So that is basically, this is f of I, this is y of I. 15 times negative 2 is negative 30. 17 times negative 1 is negative 17. That's a 0. That's 22. And that's 2 times 25 is equal to 50. And then if I add all of these numbers together to calculate sigma f of I y of I, sigma f of I y of I is equal to, basically, is equal to 77, these two numbers. And these two numbers added together would be negative 47, 0, and that's a positive 30. That's a positive 30. And then over here I have sigma f of I, which I can calculate from here. So sigma f of I is equal to all of these numbers added together. So that's 10 and 12, which is 22, 42, 43, 63, 65, 85, and 90. So these numbers, the sum of these numbers is 90. And now if I divide 30 by 90, that gives me y bar. So y bar is equal to sigma f of I y of I, which is equal to 30 divided by sigma f of I 90, which is equal to these zeros you can cancel out, and 3, 1, 3, 3, that's 1/3. So your y bar is equal to 1/3. So your y bar is equal to 1/3. Now, in order to calculate x bar, I can write a, which is basically 42.5. 42.5 plus h is equal to 4 times y bar, which is basically 1/3. So that's 1/3 here. So that's the same thing as 42.5 plus 4/3. 4/3 is, I suppose, well, the way that you can calculate it is 4/3. You can write it as 1 and 1/3. 1/3 is the same thing as 0.333 repeating, or you can write it meaning that it just keeps going 3, which you can write as basically 0.3 repeating. So now, so then you can write this number as 1.3 repeating. But since you cannot use this number in calculation, you have to round it, for example, to 1 decimal place or 2 decimal places, or depending on your needs. So over here, since I have 1 decimal place here, and well, the number of course, the decimal place is not that important really. What's important is the number of significant figures. But I don't want to get into that here. It's not the topic of this discussion. I just take it over here just arbitrarily as for example 1.3. Otherwise there is all kinds of rules and regulations related to doing such things in physics and chemistry, but we're not concerned about that here. So, but in short, what that means is that if I take, for example, some measurements, suppose that, for example, I measure some, I don't know, some length, for example. I measure some length, and I measure the length as, for example, let's not talk about this here, and it would just waste our time right now. So I just round this number to 1.3, and this number over here is, so this number would be basically 42.5 plus 1.3, which is 43.8. 43.8. That is your X bar. Let me see if the answer is correct, and then we can move to the 43.5. Maybe I have made a mistake here. Let me see. 43.5. Let's see. I have to check my numbers. So over here what we have done is that these are my f of i's, and these are the classes 32.5, 36.5, 36.5, 40.5, and 44.5, 48.5, 48.5, 52.5, and then the class marks are, let me check these class marks, 32.5 plus 36.5, and that divided by 2, 34.5, and then you have 36.5 plus 40.5 divided by 2 is 38.5, okay. Now 38.5 plus a 4 equal to 42.5. 42.5 plus a 4 is 46.5. 46.5 plus a 4 is equal to 50.5. Now if I calculate based on that, if I calculate 34.5 minus 42.5, 34.5 minus 42.5, negative 8 divided by 4 is equal to 2. And then if I calculate 38.5 minus 42.5, and that is equal to negative 4 divided by 4 is equal to negative 1. And if I calculate 46.5 minus 42.5, that would be 4, would be 1, okay. Now, f of I times y of I is equal to 2 times negative 17, 0, 22, and 25. 2 times 25 is equal to 50. Now, 50 plus 22 minus 17 minus 30 is equal to 25. Oops. That's a 25 here. Actually, I should have started with these numbers. That's a 25 here, and these numbers here are, it's very easy to make mistakes. 17, 21, 22, 25, 100. Both of them are actually wrong. I don't know how that happened. So that is 100. So now, sigma, basically x bar over here, we said that x bar is equal to basically A, which is 42.5, plus h times h is equal to 4 times basically y bar. Now y bar is equal to this number divided by this number, right? So 25 divided by 100 is 1/4. Okay, that's correct. Okay, so these two will cancel out, and then you will get this is a 1, and then you will get 42.5 plus 1, which is equal to 43.5, and that must be the right answer. That is the right answer, 43.5. So your x bar is equal to 43.5. Okay, that is that. I apologize for this mistake, but I could not make it. So, I mean, anyway, so now that we have this, we have calculated this, now we can calculate standard deviation. Standard deviation is basically sigma, and that is equal to sigma of x, meaning that standard deviation of variable x is equal to basically h over n times the square root of n times sigma of f of I y of I squared as I goes from 1 to n, minus sigma of f of I times y of I all squared and so what I need here is f of I times y of I squared, f of I times y of I squared. And so to calculate that, y of I squared is equal to, for example, 4 times 15 is equal to 60, or 1 times 17 is equal to 17, or 0 would be 0. 0 would be 0. So 1 times 22 is equal to 22. 4 times 25 is equal to 100. And so based on that, sigma of f of I y of I squared is equal to all of these numbers added together. That's 77 plus 22 is 99. That's 199. Just to make sure that I didn't make any mistakes here, let me just add these numbers together. 199. And this number over here, f of I, y of I, and sigma of that as I goes from 1 to n, we have already calculated that. So I can write this as h, which is equal to 4 divided by n, which is sigma f of I, that's 100, times the square root of n, which is equal to 100, sigma f of I y of I squared is equal to 199, minus sigma f of I y of I whole squared. That's 25 times 25 is equal to, I think, 25 squared is equal to 625. Let me see. 625. So that is 625. And take the square root of that. That is your answer. Now 4 divided by 100 is 1 to 25. 1 to 25. And then over here you have basically 1 to 25 square root of 199, 0 minus 625, that is equal to That is equal to 19900 minus 625. So you have an 8, 9, 10, and 5, 7, 2, 9, 1. That's basically the same thing as 1 by 25, the square root of 19,275. And to calculate that, you need to of course have some space. Let me make some note over here. So you have 1 over 25 square root of 19,275. And let me then basically create some space here. New layer. 430. Okay, so what we had here was basically, that was standard deviation, or sigma. Sigma was basically 1 over 25 square root of 19,275. 275. So now to calculate that, what you can do is, you could prime factorize the number, but it's too large a number. It's not worth it. So 19,275, if you take the square root of it, you get these three groups here. And then you can basically write 1 times 1 is equal to 1, subtract 0, 92 bring down. 1 plus 1 is equal to 2. So, for example, 25 times 5 is equal to 24 times 4 is equal to 16, 1, 96. So 4 and 4 would be, no, that doesn't go. So 23 times 3 is equal to 969. So that's a 3, and that is a 3. So that's 69. So 92 minus 69 is equal to, so this is 8, 12, 3, and 23. Bring down 75. Now 23, add 3 to it, you'll get 26. 1 digit here, 1 digit here. And then you have 2,300, and this is 200, so around 10 times. But there's a 60 here as well. That would be like 600 times if you multiply by 10. So 2, 6, for example, 7 times 7, you'll get, that's a 1400. That's a 420. So that's 1800. 278 times 8, 268 times 8 is equal to 1600, and you have 480, that's around 2000. 269 times 9, you'll get 1800 there, and 540 there, and around that 80 over there, so you get 0 and 12, 1, 13, 14, 240. So 9 is not possible, but you can go with 8. So 8 and 8. 8 times is equal to 64, 6. 8 times 6 is equal to 48. 8 times 6 is equal to 48. 48 plus 6 is equal to 54. And 8 times 2 is equal to 16. 16 plus 5 is equal to 21. I'm not sure if I'm right here. 8 times 268 equal to 2144. Okay. Now this makes it 2, and then it's no, that's not necessary. Okay, 5, 1, 3, and 2, 231. And then you can, for example, add a decimal point 0 here, 2 zeros, and then bring down these zeros, add them over here, add 8 to 268, add 8 to it, that's 16, 1, 7, 276, 276, 1 digit here, 1 digit here, and it will give you, you have 23,000, you have 2,700. Taking this digit into account, 2,700, so it's around 3,000. 7 times, I would say, because 7 times 14,000, 18,000, 8 or 9 times. So 2,768 times 8 gives you 16,000 there, 55,600 there, and 8 times 6 is equal to, that's 480 and that's a 64. So you get a 0, you get 8, you get a 4, 6, 10, 1, and then 7 plus 5 is equal to 12, that's 22. That's very close. And then you get a 64 there as well, so you get a 4 here, and you get a 6 plus 4, 6 plus 8 is equal to 14, and you get a 1 here, and then 2, 2. That's going to be basically this number multiplied together. 2,768 times 8 is equal to 22,144 exactly. So I write this as 8 and 8 here, and it's 22,144. 144. You subtract, you will get, so this is a 2, 11, 10, 10, 9, 10, 10. So that's a 6, that's a 5, that's a 9, that's a 0, 0. You can take it as, for example, and you can go for another decimal place as well, but it's really not necessary. So that's 138.8, for example, and the correct answer here is, oh, sorry, that's it. Let's take this as, let's take this as, let's bring down 2 more zeros, see what happens here. So that's 600, and then you need to add 2,768 and add an 8 to it. So 16, 1, 16, 1, and you have a 772, 2776. You have 2776, another digit here. So you have 95,000, and here you have 27,000, around 30,000. And this is around 90,000, so that's around 3 times or so. So if I write 2,763 times 3, that's going to give me 6 and 1, 2, 3, 4 zeros. That's 60,000. That's 21 and 3 zeros. 700, that's 21 and 2 zeros. And 18 and 1 zero. So 1 0 and 18. And this is a 9. So that's a 9. That's an 8. That's a 2. That's a 3. And that's a 9. 93,289. Exactly 3. So I take this as 93,289. And then if you we will get some remainder here. So I'll take this as 138.8. 138.8. And if you divide that by 25, 138.8, divide that by 25, what you will get is 4 times 25 is equal to 80, 100. 5 times 25 is 125. 125. So that's a 3, 1 decimal point. 138. 5 times 25 is equal to 125. Sorry, I don't want to be so careless. 3 and 1, and then you can go for another 0 here, and 5 times 25 is 125 again, and you will get some 5 remainder there. So that's 5.55. That is about, take it as 5.5 or 5.55 as stated in the book. So that is basically the end of these exercises. Well, one thing that I have learned about myself is that it's absolutely not enough, at least for me. And I think that's why nothing worked for me in any sort of educational system. I mean, I'm not young anymore, but I'm about 40 years old, or exactly 40 years old. When I was a kid, I couldn't get past the 10th grade. Back then I was living in Iran. I couldn't get past the 10th grade for different reasons. First of all, I didn't agree with the education system. I didn't agree with the school. I didn't need the education really, because I was good at electronics, so I started some sort of business for myself for like 10-15 years. And then after that, when I was 27, I went to India. And in India, when you get into those colleges, you get into some sort of, for example, college or university. And I was doing, at the time, I wanted to do a computer engineering course. So you get into some sort of very competitive system. And in a competitive system, well, you have to be competitive, you have to be very fast. And of course, the kids that they were actually doing the course with me, so they had done all of this mathematics and a lot more. Indians are pretty good at mathematics, although not most of them, not at least every one of them does understand the meaning of what they read. Most of them probably just memorize things. I saw that myself. But anyway, that's not the point. The point is that it's not enough for me to go through and then I had to get out of that college, and I never finished that course. Now, the point is that for me, I do need to understand the concept, meaning that I need to read the concept, and moreover, I need to do as many exercises as necessary in order to get the hang of the formulas. But then when I do that, then there is really nothing that I cannot do if I do that, if I take the time and understand everything about the concept, do enough exercises, and that takes really long time. For example, for this chapter of this book, which is around only 36 pages, it's taken me like, I don't know, 4 to 5 days. I had to go back to the, as you saw, I had to go back to the previous chapter of class 10 to review that, because I had forgotten that, and there was these problems with the concept that I had to cover, and then again come back to basically the material that we have here. So for example, for me, I have to take the time and really understand the concept. So for many people, it might be actually exactly like this, or something like this at least. If you don't understand something, it doesn't mean that it doesn't mean that you're not destined for this kind of thing, or that's not in your destiny, or you just don't understand mathematics, or you don't understand physics. These are basically logical things, and logic means that you have to understand it. If you don't understand it, it's very simple, you just haven't understood it. And when something logical, you don't understand it, it always gets back at you. You cannot go anywhere until you have taken care of the problem. And of course, you already know that basically, for example, the statistics that, for example, you're learning here, this statistics is the exact same thing that is used in computer science, is in data science, in computer learning, in artificial intelligence, in machine learning, and in all of these things. The only thing that scientists do is just these very simple high school topics. Even if you go all the way up to a PhD, basically from your undergrad school or to the graduate school, and while you're doing your PhD, all that you're doing is just doing the same simple, basically, statistics that you study in high school. So you just need to take the time to understand it. There is no other way there is really no other way. I mean, basically, you just don't rush it, right? Take your time to understand the material. Okay, so the next thing that we have here is analysis of frequency distributions. So we will go through these as well. Let's see what they are. I'll see you in the next video. Thank you.